Hello my dear students, welcome you to the lecture 3 of the chapter Motion in a Straight Line. Let's see what all are the concepts that we are going to discuss in this lecture. Okay, here we will be discussing about speed and velocity, average speed and average velocity, uniform motion and non-uniform motion, instantaneous speed and instantaneous velocity. Now, let's have a comparative learning about speed and velocity. What is meant by speed? Speed is the distance per unit time. Okay. Whereas velocity is the displacement of a body per unit time. It is very simple to remember that because speed is a scalar quantity. Okay. Distance is also a scalar quantity. So that speed is distance by time. Clear? Whereas when you say velocity, velocity is a vector quantity and displacement is also a vector quantity. So you can say that velocity is the displacement of a body per unit time. Clear? So now let's see how to give them equations. For speed, the equation is speed is equal to distance by time. Okay, and velocity is displacement by time. Okay, and now you know that speed is a scalar quantity and velocity is a vector quantity. Then speed can be 0 or positive and velocity can be negative, 0 or positive. When the displacement is negative, the velocity is also negative. Okay. Now the SI unit for speed, you know, the SI unit for distance is meter and for time is second. So here the SI unit is meter per second. Okay, and for velocity also it is meter per second. And I will give you a very important relation, that is velocity. I'll change the pen color. Okay, velocity is less than or equal to speed. Okay, velocity is less than or equal to speed. Clear? Now, let's see what is meant by average speed and average velocity. You know that practically a body cannot travel with the same speed, right? Why? There can be traffic situations like this, and also the road through which the body is moving or the path through which the body is moving may not be smooth, right? It may have some cracks like this. Okay, so what happens? The speed of the body will be varying. In that situation, we will be considering a average speed or an average velocity. Okay, so how can you define average speed? It is the ratio of total distance traveled by a body to the total time taken. Okay, whereas average velocity is the ratio of total displacement of the body to the total time taken. Okay, so we will be considering an average speed for that entire motion. Okay, so how can you write the equation? You can write average speed is equal to total distance by total time. Okay, now how can you write the equation for average velocity? Average velocity is equal to total displacement by total time. Okay, and you know that average speed is a scalar quantity and average velocity is a vector quantity. And average speed can be 0 or positive, and average velocity can be negative, 0 or positive. Okay, and what about the SI unit? Whether it is average or total, whatever it may be, it is speed, right? So the SI unit will be meter per second or total distance. Unit for distance is meter, unit for time is second, so it is meter per second. Okay, so the SI unit is meter per second and average velocity, the unit is meter per second. Here also you can tell that same relation as we discussed in distance displacement, speed velocity. What is it? Yes, the average velocity is less than or equal to average speed. Okay, I'll give you that. Let's write here. Average velocity less than or equal to average speed. Clear? Okay. Now, in order to do the numerical questions, I will tell you two simple equations that can be used in a special situation. Okay, that is case 1. Suppose a body want to move from A to B. Okay, then if the body travel half of the distance, okay, that's right, half of the distance, okay, half of the distance with a velocity u, and other half of the distance, okay, other half of the distance with a velocity v. Okay, then what will be the average speed, okay, or average speed or average velocity as the question demand. Okay, so we can write v average is equal to 2uv by u plus v. Okay, this is the equation, 2uv by u plus v. Clear? Now another case, I will tell you another case. Case 2. A body want to travel from A to a position B. Okay, now if the body travel half of the time, okay, in the previous case it was half of the distance, and in this case it is half of the time. Okay, so half of the time, with a velocity u and other half of the time with a velocity v. Okay, then what will be the average speed or average velocity? The v average will be u plus v by 2. Okay, so you have to remember these two equations for doing the problems. Okay, now let's learn what is mean by uniform motion and non-uniform motion. Before learning what is uniform motion and non-uniform motion, you need to know that the word uniform means constant. Okay, so the word uniform means constant. Constant means it will not change. Okay, it will not change. Okay, non-uniform means it is varying. Okay, so it will change as the time passes, because time is our independent quantity. Okay, you remember that, right? Okay, now let's say what is mean by uniform motion. Uniform motion means a body is moving with a constant velocity or speed. Clear, as we are considering straight line motion. Okay, and non-uniform motion means the body travel with a varying speed or velocity. Clear? Now If the body is traveling with a constant speed, then that body will have equal displacement or equal distance in equal interval of time. Okay, I will explain you that more clearly. And non-uniform motion, the body will have unequal distance or displacement in equal interval of time. Then that motion will become a non-uniform motion. Okay. Then since the speed is not changing or the velocity is not changing, right? As the velocity does not change, the body will not have acceleration. You know what is meant by accelerator, right? Your vehicle will have an accelerator. And why you use that? In order to increase the speed, right? So to change the speed, when there is a change in the speed, there will be an acceleration. Okay. So in uniform motion, the body has a constant speed or velocity, right? Since the velocity is constant, the acceleration is 0. Clear? And in the other case, that is non-uniform motion, the body will have a acceleration. Okay, that is the acceleration is not 0. Now I will explain more with the second point. Okay, that is, I'll give an example for that. Our second point was, that is, a body will have equal distance or displacement in equal interval of time, then that motion become uniform, right? So let's see that. Let's consider the motion of a body. Here we plot the time, 0 second, 2 second, 4 second, 6 second, and so on. Okay, that is equal interval, 2 second gap. Okay. Now if the distance covered by the body is in 0 second, it is 0 meter, the body does not start the motion. Okay. In 2 second it is 10 meter, in 4 second it is 20 meter, and in 6 second it is 30 meter. Now in equal interval of time, let's find the speed. Okay. Let's find the speed. In the first interval, that is 0 to 2 second. Okay, 0 to 2 second. How to find the speed? You know that speed is equal to distance by time. Speed is equal to distance by time. Alright. So here the distance is 10 meter by the time is 2 second. So 10 by 2 is 5 meter per second is your answer, right? Now let's consider the second interval, that is 2 second to 4 second. Okay. 2 second to 4 second. Again, your distance is 10 meter. The time interval is 2. Again, you get the answer as 5. Now from 4 second to 6 second, your distance is 10 meter again. And the time is 2 second. Okay, so your answer is 5 meter per second. So you can clearly see from this example that when the distance covered is equal, that is 10 meter, right? Here. In equal interval of time, then your speed remains the same, that is 5 meter per second. So the body is traveling with a uniform speed, uniform motion. Okay. Now, if the body have unequal distance, right? Let's see that also. Here is the origin. We consider that as 0 seconds. Okay, we are plotting the time 0 second, 2 second, 4 second, and 6 second. Okay, that is equal interval of time. Suppose in 0 second is 0 meter, in 2 seconds it have covered 10 meter, then 15 meter, then 30 meters. Clear? Now let's find out the speed in equal interval of time. Okay, that is first from 0 to 2 second. Again you can use the equation, speed is equal to distance by time. So here the distance is 10 and the time is 2. So your answer is 5 meter per second. From 2 second to 4 second, your distance is just 5 meters, right? So it is 5 by 2, which is 2.5 meter per second. Again, from 4 second to 6 second, your distance is 15 meter, right? 30 minus 15 is 15 meter. And it is 15 by time interval is 2, so 15 by 2 is 7.5 meter per second. So when the body have unequal displacement or distance in equal interval of time, the speed or velocity will be varying. That is, the body have a non-uniform motion. Clear? Now, let's discuss what is meant by instantaneous speed or instantaneous velocity. Okay, that is the speed of the body or the velocity of the body at a particular instant of time. Okay, at this moment, if you are looking at your speed, okay, at this moment, when I am telling this, okay, at that fraction of time, that small time, okay, very small time, at that instant of time, what is the speed of that body? Then that is called as instantaneous speed or even instantaneous velocity. Clear? Now, let's see the equation for instantaneous speed or velocity. Suppose a body is traveling from A to B, okay, and let's consider a small path length, that is dx, okay, then the time taken to cover that small path length will be dt, right? Okay, see, the actual concept of this should be explained using the limit concept in mathematics, okay, but currently you are not familiar with all those things. So I am giving you very simplified concept so that you can understand this very well. Okay, and later you will learn how to do differentiation and all. Okay, calculus, I will be explaining you. From that time onwards, you will be doing the problems based on this. Clear? Okay, so for now you need to understand, right? For that purpose, I have simplified it. Okay, so the small one is represented using d. Okay, you remember like that. For the small one, you give d. So here the small path length, that is dx, and the time taken to cover that small path length will be dt, right? So at that moment, what will be the velocity? That velocity is distance by time, sorry, displacement by time. Okay, speed is distance by time. Then here, that instantaneous speed or instantaneous velocity is dx upon dt. Clear? This is the equation. Okay, now it is differentiation that comes from calculus. I will explain you later. Okay, now here you can see a picture, right? What is it? Yes, this is the speedometer. Okay, you know that our vehicle have a speedometer, right? And the speedometer show average speed or average velocity, which will be shown there. Yes, it is average speed. Why? Average velocity means it's a vector quantity. You need a direction, right? And average speed is actually the magnitude part of the average velocity. Clear? That is, we does not consider the direction to tell the speed. When you look at the speedometer of your vehicle, you are getting a value at that instant, right? Speed, that is the speed of your vehicle. It does not tell you your direction. So your speedometer of the vehicle is giving you the average speed. Okay. So we have covered many concepts like speed and velocity, average speed, uniform motion, instantaneous speed and instantaneous velocity. And in the lecture 4, we will be discussing the problems based on our current lecture, that is lecture 3. See you all on there. Bye bye.